Hey, thanks, Jim. Hello, everyone. Yeah, I'm Suresh Mathew, founder and CEO of Sedai. I was at PayPal. I joined PayPal in 2008. In fact, in eBay, while eBay and PayPal were together. In 2015, when eBay decided to spin PayPal off as a separate company, I joined PayPal and continued the journey there. 2015 is when we built our first autonomous system. And that's the system that's powering PayPal even today. So it's 2025, 10 years. That system is still running production for PayPal. That's where we got this idea, and that's how we started the company. So today we will be talking about over-provisioning as a problem statement and how AI can solve it for you. It's strictly not just over-provisioning, it's incorrect provisioning. It could be under or over, but typically it's over-provisioning. And I'll tell you why it's typically over-provisioning or commonly over-provisioning and not under-provisioning. It's a masterclass, so we'll talk about the problem, deep about the problem. We'll talk about the typical solutions here and how and why AI is required. Typically, I see a lot of people running into AI. Here, we'll talk absolutely about why we need AI, and that's the only way to solve this. And autonomy and levels of it, real application, a customer using it, and the results there. And I'll also show a live demo. Questions, as Jim mentioned, feel free to ask in between. And I generally like conversations than one-way monotonous talk, so please feel free to ask. Stop me and ask. Perfect. So we see this as a problem statement in cloud. Every time when I read a paper about wastage, I see over-provisioning being the number one culprit. And it is almost the same across company, across industry, the size of the company, maturity of the company. And the numbers are really significant. The biggest problem, the number has been here for the past 10 years or maybe 8 years. If you read up Gartner, you can see that the wastage has been around like 20 to 40% at all times. The biggest problem or the wrongdoing of all the companies that were trying to solve this was they were all trying to solve the symptom and not the problem. The problem is you are trying to fix a configuration that was done wrong. Somebody configured CPU at 2 while it had to be at 1, and you brought it down to 1. The biggest problem is the reason why it was at 2 was never addressed. And it is because people are generally a lot smarter than configuring a provisioning configuration for a cloud. For instance, if an app comes up, although people know that it had to be at 2, they will generally configure it at 4. Because if you configure it at 2, chances of you getting a late night call to resolve a problem is fairly high. The smart way to configure it is to configure it at 5 or 4. So you don't get that call. If you have a new feature, you already have configured it at a level that the feature can handle, the configuration can handle the new feature. So generally as a defensive configuration. And that's exactly the problem. So you don't really fix that configuration. You fix the root cause, which is you're asking a smart person to put a configuration that he is not interested in configuring. And you need to have a lot of data to configure, right? You need to learn all the metrics. You need to know how your application behaves. You need to know the traffic. You need to know the behavior of your dependencies. You need to know the version. You need to know a lot of things to really configure it right. And they call it LNP. LNP is an extremely hard problem in production. So that's the crux of that problem statement. And to amplify this problem statement, now this happens in cloud in current world, which means now there are a lot of microservices. There are a lot of such configurations in play. There are a lot of options for you to, right? You have Kubernetes, you have container services, you have serverless applications, you have VMs, you have a lot of configurations in play. It makes this configuration extremely hard for humans. And again, generally these admins are not excited about configuring something right because it's really wastage removal. It's such a boring, mundane task. So it is the problem statement can be fixed with a cleanup, like having a sprint that can focus just on wastage, removing everything, doing your LNP right, and making sure that things are good. But it's going to go back again because the fundamental issue is still there, which is we are asking engineers to configure this while they are not super interested in this. So the problem statement is really asking the wrong question to the wrong group. If you ask engineers to configure, they are going to do the smart way, which is configuring it above limit. So instead of one, they will be doing two. And that's a smart way to do it. And I would have done the same. I'm an engineer at heart, so I would have done the same. And now the first attempt to solve this was auto scaling in multiple different ways. There were rules on the framework itself. For example, Kubernetes is a great example. You can have an HPA or a VPA in play. You can have a configuration there that says if CPU goes above, say, 80% or 75%, add 2 pods to it. Let's go deep into the rule here. There are a lot of parameters here that are all configured. One is CPU itself, the metric that's chosen. It could be CPU, it could be memory, it could be latency, but generally people choose the easy metric, which is CPU. We all choose that. The second is the number 80, right? The limit here. It could be 80, it could be 75, it could be 60, it could be 50. Generally, we chose a very defensive metric. It could be typically 50 or 60. 80 is very aggressive. Then the third number here is how many pods should I add? How many number of VMs or tasks or pods should I add when this happens? Then the max number of pods that I can have. So this is a lot of configuration. It mimics an autonomous system, but if you look at deep into the system, it is really automated, which means all these configurations are again thrown back at the developer. Tell me what is your metric. Developer answers CPU, because I don't know what metric it is. CPU is the easiest. Tell me what is a number. Developer answers like 50. Tell me what exactly is the number of pods you want to add. So all these are questions to developers while they are really interested in writing code and building new things. They are builders. You're asking configurations. You're asking a super boring question, a risky question to them. So that's why they generally answer very defensive, so they can go back to their mainstream of work. In case if you guys have any questions in between, please feel free to ask. And this is why we believe AI is the only solution here. The thing that you have to stop is not to fix that 80% or that 50% there or CPU there. It's really asking that question to a developer. That's the process that needs to be fixed. Be it a configuration, be it the metric name, be it the configuration, it is really asking that question. So you have to stop asking that question to the developer. You have to tell them, write your code and we will figure out how exactly can we scale, how exactly can we right size. That's why we call it an AI-based system or an autonomous system. The system decides what is your configuration, what is your scale parameter, and it does it for you. Let's take an example of such an autonomous system, which is SEDI, which is the company that I'm from. What it does is it has a set of agents in play. And these agents have tasks for themselves. They have their own affinity. There's the cost agent. Its job is to make sure that the cost is matched with the user request. Second is a performance agent, making sure that the latency is the minimum. The third is the availability agent. That's like an agent that can trump the questions, the affinity of the other two. That takes the highest priority. And the fourth is the safety agent. So these agents work together to figure out what is the right configuration for your application.
So, Suresh, while you're on the screen and as you're thinking through this, Patrick has a question, and then maybe it's thinking of tools like Cloud Health or other things. Wondering if today's automation solutions are not enough to solve the problem. Like, are they missing some parts, and you might be getting into the number of agents that you have here.
Yeah. Yes, that is not enough to solve the problem, and that has been proven. We have that proof, right? Time and time again, we have been trying multiple things, but the real problem is asking that question somehow to that developer. So you have to rely on an autonomous system or an AI agent to configure it for you. So all these systems would help you figure out where you are wasting money or where you're spending money. The solution is still, so far, is still automation. That's why we built this company. So the solution becomes autonomy, right? Figure out your metrics, build that model that understands your application deeply, or four golden metrics: latency, errors, traffic, and resource usage. We bring all the metrics together from your monitoring provider. We connect to your monitoring provider, get all the metrics together. We build that model. That model tells us how to configure the application. And the good thing about that model is it understands the availability criteria and will make sure that there is not even one incident when this happens. So the usual way of doing it, which is rules and configurations, gets changed to an autonomous system that learns your application and figures out those rules. The same example that I said, autoscaler has a rule there. If CPU goes above 50, do this. You need to have an autonomous system that can configure that rule for you. That rule is not enough. That's automation. You need to have a system that can configure it. And today, as far as I know, SEDI is the only autonomous system, but I'm not here to just sell SEDI. Okay. So if you want to build, what I suggest is either build an autonomous system, which I would 100% happily help you with, or adopt autonomy. Patrick, I assume I have answered that question.
Yep.
Perfect. And the outcome here. So now let's talk about the architecture of this. So generally, when an autonomous system goes in, it's almost like a DevOps engineer going into your production. It has to understand all the metrics of your application, the layout of your architecture, which is all done through APIs. Once it understands it, it needs to know what exactly are you doing today. So that's why it connects to ServiceNow or Jira and understands what are the changes coming in. That's how it starts learning. Now it understands how your application is reacting to traffic. What exactly is it doing? What can we change? And what am I seeing in production? So it's all about understanding your application really, really well so it can start configuring this for you. It needs to know when your application gets changed. So everything is connections through APIs. So when we get onboarded, the thing that we do is connect to all these systems like an engineer getting onboarded. It's done in less than 15 minutes, and then we start building the model. And that model figures out what are the opportunities that I can now see that to optimize. Optimization could be optimizing in terms of performance, in terms of availability, or in terms of cost. Then it looks for the right time to execute the change, and it executes the change. And when it executes a change, it executes like an operator executing it. It files a ticket, it makes sure that it gets approval, and then it does it. It also monitors the rest of the dependencies to make sure that the change hasn't caused an issue.
So Suresh, on the so it sounds like it's integrated with things like you can integrate an autonomous system if you want to do it well. You still want to track the changes that that system is doing, and so there's the agent there is able to communicate with ServiceNow or other ticketing system via API. Have you found that at places with a large set of workloads, does ServiceNow ever throttle your APIs in a way that kind of slow an autonomous system down?
Yes. So we generally have speed breakers everywhere. We do understand that we can pull data pretty quickly, but at the same time, we need speed breakers, not just for ServiceNow, even for monitoring systems. We have seen CloudWatch slowing us down, Datadog slowing us down. We generally bash them.
Gotcha. So you've run into the problem of being throttled, but have ways to not maybe not do bursty traffic, but you send the traffic outbound to those systems you're integrated with. So
Exactly.
So you don't overwhelm them, but keep able to perform whatever you need to perform.
Yeah, I've noted it down. During my demo, I'll show you a platform that tracks everything that we do. We generally track all the API calls that we make. We know the rates. We also adjust the rates on the fly.
All right, cool.
Perfect. Now, this is where let's spend some time here, right? So there were a few options for me when I was at PayPal to fix a problem that I saw in PayPal. There were a lot of issues that I saw that people were on calls handling. There were availability issues, late night calls, figuring out what needs to be done. And the next step for people was to really automate it, like learn and see if we can do some runbook automation. So these issues, when they happen, people can execute those changes. That was the first step to automation. That's the automation phase. There are two problems there again. One is there could be accidents and it's quite risky. At times, people might execute a runbook that's not the right runbook for the issue at hand. They might think that the issue is exactly the issue that we saw last, and it may not be. That delays the fix as well. The second is it is not applicable at scale. It becomes hard to run automation at scale. So at PayPal, what I did was built a system that could look at all the metrics, figures out what exactly is happening. It can also take the first stab at the problem. It could be fixed with a restart, a simple restart, or it might need something like a patch, right? And it does it autonomously for the user. Now, when it comes to figuring out a problem, we generally regress it ahead of time, in the sense we predict it ahead of time. So before an issue happens, when the symptom starts, we start looking at that problem. When I say we, it is that autonomous system. So that way, by the time we finish the issue, we still have time to call the user in case if there's a problem that we cannot fix. So it's almost like the frontline warrior for you. Symptom happens, the first the system at PayPal takes the first stab at it, looks at the problem, sees if it can fix the issue. If it cannot, it'll call the developer. Now, we were able to handle more than 80% of issues this way. If you look at PayPal's reliability, it went to 5 nines in under 6 months once we established the system there. The code name inside PayPal, it's called Nix. That's what we built at PayPal. And that's a system today running it. Now, the difference between automation and autonomy and why we call it very differently, I'll take the example of Waymo versus Uber, right? So it's all about, do you have a driver in the front row? And if there's an accident, the driver will be blamed. If you do not have a driver in the front row, the cab has to take the blame. That's an autonomous system. The good thing about that is that autonomous system will know in and out of every operation it's doing. So far, we have done more than 5 million operations since the birth of this company. We have not caused one single issue ever, one single issue. And it's a hard statement to make. I know I may sound like selling snake oil. No, there is no way this company can survive if we make an issue, because our customers are the best in the world. Right? They are the best cybersecurity company, the best credit company, the best pharma. They are all our customers. The best bank. They are all our customers. When I say best, the largest. Now, when these are our customers, if we make an issue there, it's going to be known. And I think that probably is the last day of Saddam. So that's a good thing about an autonomous system. The chances of you having an accident is fairly low because the models are that strong. What essentially you do is you find all the things that you're extremely confident that you can take an action. And there are like streams of machine learning that can help you there. There is a stream called, I'm not sure how familiar are you with machine learning in general. Reinforcement learning is supposed to really help you there. So RL is the key for this. So if you have a proper RL, then you can really make these changes beautifully.
So, Suresh, I have a quick question on with the rise of generative AI, and when everybody says AI, they think ChatGPT. Do you find that you have to talk to customers and tell them that it's a real scientific machine learning model that you guys have on the back end and not a generative language model, large language model?
Yeah, large language models are extremely good at giving you recommendations. Decisioning is hard. So for decisioning, you need an RL, and that's what we rely on. So a generative AI helps interact with SEDI. So there's a way to interact with SEDI using Gen AI, but for decisioning we use RL.
Good to
And
know.
yeah, I get that question from the customers, yes, and I answer it. I think that although there is a rush towards it, people are more comfortable when they realize that you're not using LLMs, especially in production.
Yep.
Perfect. And let me take you to a customer testimonial. Again, so we have named the customer here. This is Palo Alto Networks, the largest cybersecurity company in the world. They run on our system. So we manage their applications. And the reason is, again, they have thorough services. They have a lot of services and they want to manage all of it autonomously. And they cannot afford to have a single issue. And that's when Ramesh decided to use SEDI. And we have done more than, I'm thinking, close to 100,000 operations in the last 6 months. Not even one issue. Meaning we have been optimizing their applications all this time without a single issue. That's the strength of a model. So and as I mentioned, right, this is not just about SEDI. It's not just about selling the product. It's about making sure that you guys, all of us, are helping the developers really run production safely. So if you ever are interested in building a model, building a system, we are down. So I mean, the whole company would support you. Let us know, and we'll be more than happy to help you. In case if you don't want to, we are more than happy to help you with our other platform too. And this is the outcome of that system. Again, in the last 6 months, we have done around 89K operations, and that saved them in hard savings $3.5 million with 0 incidents. And they didn't have to click a button to get there. Right. We'll go through a quick demo now. Any questions so far?
On the it's always tricky a dollar amount saved because people's environments are dynamic. Maybe I have 10 workloads today and 20 workloads tomorrow. Is there some kind of rationalization that you do in order to figure out that that number saved? Obviously, there's something saved, but in such a dynamic environment, any tricks on how to tease out that savings for us? That'll be having to figure out ROIs. Whether we build something on our own or use something like SIDI.
Yeah. So typically, when you do a POC with a company like SEDI, we will tell you what exactly is our estimated savings. Again, that's an estimate only. I have not seen anything less than 20% ever in what we have covered. Now, one way for you to take an estimate is looking at the usage and looking at the subscription, and one minus the other is roughly the savings that you would get. Now, how to get there is the tricky part. Right? Getting there is probably the hardest. So, a rough estimate would be that. And it is also a good idea to connect your billing account so we know your plans, your savings, so we can give you an exact number and not really the listed price. And we do have the basic FinOps reporting as well, like how much are you spending, where are you spending, and what are the savings plan, what is our recommended savings plan. Those basic FinOps functionality is also there.
All right, great. Yeah, let's jump into the demo. Actually, there's one question. A couple questions came in while we were chatting. Chandra has one. How does the system measure the percentage of incidents caused by AI decisions versus other factors? Maybe there was an outage during that time window when SEDI was turned on. How do you avoid getting blamed for an outage, I guess?
How do we avoid getting blamed for an outage?
Yeah, maybe somebody changed something or pushed some bad code, so there's an outage, and it's like being the network guy. Everybody always blames the network guy for an outage.
No, that happens all the time, and it's okay to suspect everyone. Generally, we have the audit logs of everything that we do. So when we make a change, ServiceNow will have the record of it. So when an incident happens, they'll go back and look at what SEDI has done. And like if like any enterprise, there is a kill switch for SEDI. So in case if there's an outage, they can come to SEDI and say, stop everything because I'm going to debug something. It's not because SEDI caused the incident, but SEDI acts almost like a human, right? You can talk to SEDI and say, do not do anything more because I'm debugging something, and it'll honor that. And the audit logs is available everywhere. And the second question.
So there's a second question from Patrick. So in what situations will current automation systems like Terraform continue to be useful? And is SEDI most useful for very large infrastructure situations like Palo Alto? Maybe you're at a smaller company and the footprint's not very big. So there's two questions there. One is, does Terraform become less useful if there's automation systems like SEDI? And then is this type of optimization only good for large footprints?
Got it. I'll take the first question first, the Terraform part. So Terraform is a beautiful technology. Yes, you should continue using IAC, and we send our changes back to your IAC as a PR. So when SEDI makes a change, it doesn't make the change independently. It'll make the change and send the change back to you as a PR. So your developers have access to what SEDI thinks of your production, and it's updated at all times. And second, the large infrastructure aspect. I don't know that, and I don't know the right answer there. In my mind, you need to have enough traffic for the model to learn. So there has to be enough things in data in the platform for it to learn. So if it's like a 5 application company, I would suggest not to use or build an autonomous system. Once you cross, a golden number would be $1 million cloud usage, maybe the right time to think of an autonomous system. That is all the data we need to learn. So you don't have to be as big as Palo Alto. We have customers, a billion-dollar company also as our customer. So it's not just Palo Altos.
All right, great.
Perfect. Let's quickly go to a demo. Now you can see my application screen, I'm assuming.
You can see the screen. Can you make it a little bit bigger? The font is a little small. Right, yeah, screen's bigger.
Other way around now. Okay. Better?
Yep, there we go.
All right. So this is the home screen where we talk about what is in autopilot for. This is our stage environment, by the way. This is not a customer environment. This is my stage. And what is autopilot and what is on availability and on optimization? The opportunities that we see for optimization, the SLOs that you have established or we have established, and the releases that you have done, and the activities that we are doing on this platform. And I'll show you first a FinOps-like screen. If you're familiar with FinOps platforms, generally this is what FinOps companies would show you. Current spend, the savings, and the spend after that. So this is exactly like any other FinOps company. There are like 90 FinOps companies in the world today, and all of them have the same screen, including Google, Azure, and AWS. So you don't have to buy any company, any vendor to just get the screen. So in my mind, this is a screen that you can build with a few Excel sheets yourself. Where we make a difference is here. Out of that savings, a 7K savings is already back in your bank account because SEDI made those changes. So this is what an autonomous system could do for you too. Once the system has learned your application, it understood what's going on, it can start making changes. So you save that money that you saw in the first screen. So ideally, with an autonomous system, that screen should be small enough that you can now manage it with one or two people. And again, not all changes can be done autonomously. There are changes that would need manual intervention, and those are the changes where I would say, I think this can be made, but I don't want to make change because I'm not confident. But there are a lot of changes where I say, I'm super confident I'm going to make the change. Let's take a look at this. This is an ECS application, if I'm not wrong. I know this is a GDG group, but still, this is an ECS application. And you can see the changes here. From 512, the CPU went down to 256. And you can see us tracking both and your containers as well. So we look at at any point, we always look at your latency to make sure that has zero impact on this change, with this change. And let's take a Kubernetes application here. In this case, the memory got increased and the CPU got decreased. So if you look at this, right, so that's where the right sizing would come in play. In most cases, you would see that SEDI is looking for the right configuration for your application in terms of latency and errors. And that configuration would mean that it might increase resource limits, or it might decrease, it might lower it. In both cases, it's going to help you reach your latency and error criteria so the application runs smoothly. The best aspect here is this is all done with your production data. And when we make a change, I'll show you the steps also quickly. So in this case, we saw an execution duration, which is, so this was a Lambda, and it started running, taking a lot of time to execute. This is anomaly detection use case. But we saw that there is something wrong, you released something or you did something that your Lambda started taking a long time. And what we did is we understood that we had to change the timeout because memory increase is not going to fix it. And we changed the timeout. So this is not just about cost, it's about cost and availability. So this is where autonomous systems can shine. It's not just about cost, it's about cost, performance, and availability. Anytime you manage cost, you will have an availability incident. In most cases, you will run into some other incident and you will have to retreat. So that's why we take all three into account when you take that initiative in the first place.
So a quick question on that topic, Suresh. So say I have my infrastructure and my application are perfectly in tune. There's no money on cost to be saved, but the autonomous system is watching all the metrics, watching them, and maybe for some reason the system starts slowing down, the anomaly detection finds it, and maybe it can figure out that it needs more or networking or memory to overcome a problem. Sedai will do something like that, even though there's no cost improvement to be made. It can help me with the slowdown while I'm sleeping. Like it can handle it in the middle of the night for me.
Yeah, wherever it thinks it can fix it, it'll fix it for you. Wherever it thinks there is a slowdown and it needs to notify you, it'll do that too. For example, as in your example, if that issue that we just saw cannot be fixed with Sedai, or Sedai is like activities cannot fix it, it'll send you a notification saying we are seeing a slowdown and it's unusual. Your traffic is not going up. You may want to look into it.
So it'll be integrated with PagerDuty or whatever notification system that we have. Send it a page. Somebody should come look at this. Okay.
Correct. And it'll also show you, give you all the data that he needs to debug that issue too. So we'll tell you what all systems degrade at that time and what are the related metrics available.
All right. No, that's pretty cool.
Okay. And these are all examples of that. Unusual tendency is, again, this is not a latency that we saw with the current traffic. So it's unusual, so it did something to fix it. Rolling reboot, again, there could be a memory leak, and it saw that, you know what, I have to reboot this because there is a leak in the application. I don't want the customer to suffer. There is a problem with the application, but we will fix it when the developer comes online. But until then, I'm going to reboot until the issue is fixed. So it really is handling as a front warrior for you. Not just cost, performance, and availability too. I'll also take the steps that we go through when this happens. So we first do a safety check, making sure that we can make this change. We have seen this traffic before. Then we acquire a distributed lock to guarantee mutual exclusion. Then we create a ServiceNow or a Jira ticket, making sure you have audit logs of every single thing that's happening in production, verifying that the ticket is approved. Then we make the change. So it is a methodical execution of things, and you can stop it at any time. And to answer your other question on the remediations that we do, these are all the things that we can do for you. And you can turn it on and off based on what you like Sedai to manage. And there is another module, we call it release intelligence. Since we now have a good model of your application, we thought, you know what, can we qualify your releases to a little bit? So we watch your releases, your changes, and then give you a scorecard based on what we see. If you make a change to your application that increase your cost, then we'll say, you know what, this has a score of between -10 to 10. It's a score of -1 because you increase the cost without adding a lot of features. Let me see if I can show you an example of that. Yeah, so you can see all the history of releases, and all the green ones are good releases, meaning they all got positive scores. And red ones are all not so good releases, where we saw that it either increased cost or cost errors or increased latency. And you can go back in time and say, what was the check-in that caused the problem? And you can take a look at the check-in and look at the configuration that caused the problem. So there are a lot of good things about building an autonomous system. Once you have that system, you can ask a lot of questions to that system. From a developer standpoint, you can ask, okay, these are the changes that I made. How do you like it? Do I impact this other application that's somewhere else? Because now that you have the model, it understands what exactly are the dependencies, what is the impact on every change, and it can answer smartly.
As far as those, it's monitoring and seeing things. Do we have to have certain telemetry sent to my my Datadog or my Google Cloud Operations Suite? Do I need to have like open telemetry turned on in order for SEDI to understand how things are linked together, or is there a different way that it can figure it out without having something like open telemetry metrics?
Yeah, we can read OUTEL and we can read from almost all monitoring providers. You can configure your monitoring provider in our settings, and we start pulling the data from that monitoring provider. So it could be Datadog, Prometheus, New Relic, or whatever system you have, and then we start pulling the data. If it is an OUTEL format, we read that data too.
But as far as application relationships, do those have to be defined somewhere else for you to figure that out, or is somehow the learning model knows that I have microservice A, and when that changed, microservice C started having a problem? Does it just know that there's a time bound problem? Maybe they're related, or did it figure out that they actually are related? Does that question make sense?
Yeah, let me make sure that I understood the question. So 2 questions in my mind there, and that one question. The first is, how do we map a metric to an app? That's one. And the second is, if an app 1 changes, how do we know that it has an impact on app 2?
Yep.
Okay. So first one, typically, if the naming convention has some parameters, we'll do that. Otherwise, it's generally tags. Right? You will have a tag saying, you know what, this is application name there, or this is application name in your monitoring system, and that's what we honor. And that's how we map it together. On your dependency between app 1 and app 2, if you have a service mesh in play, we read service mesh. That's one option. Mm-hmm. If you don't have that, we use TSDBs. For example, app 1 gets a traffic. Right after that, you see app 2 getting triggered. After some time, it understands that app 1 calls app
2. Okay, no, that makes sense.
Then you can connect your billing account here. You can connect your IAC here. This is where I talked about how we send those changes back as a PR to your GitHub, so it stays in sync. Then you have notification systems, including Slack, PagerDuty, all those things. We have runbook automation, that's also given here, and then Jira versus ServiceNow as a ticketing system. We support all 3 clouds. Google, the largest GK customer, is also our customer. Google, AWS, Azure, all 3. Okay, we also talked about the APIs. Let me show you that quickly. So this is where we keep an eye on all the API calls that we make, the rate limiting that we talked about, right? And we know how many API calls are being made and what is the cost of that. So we generally adjust it when we see that. So we keep an eye on everything every API that we make, and we see slowness. We see it us getting rate limited, and we slow it down based on that.
No, that's great.
And there's a basic cost observability as well. You can figure out the plans that you have, what are the plans that we suggest that you have, things of that nature. These are the commitments that you have. This is commitment usage. This is what is recommended for you as a commitment. Where do we see anomalies here? We also track budgets. You can create a budget and we will track it. You can create tags and manage it here. So the basic FinOps functionality is also here. Again, this is not just a FinOps tool. It's a FinOps and optimization tool, but it still has a basic FinOps, so you don't use two tools for the same thing.
There are, if I'm using spot instances at all, is there any special monitoring that you do for spot instances or recommendations that are made for spots?
Yes. Let me show you that quickly. There is spot is considered here. Fargate is considered here, and I'm just trying to figure out where exactly was that. Yeah, right here. So you can say it is you want a spot based optimization or just the usual optimization. So we generally ask the cluster itself that we need to have like 10% spot there, and it's not just a 10%. We add scale up a little bit so your spot availability can also be considered there. So it's a mix of things.
And then on some, the different clouds have different names for it, but committed use discounts or reserved instances or other things where you make a multi-year, well, sometimes multi-year commitment to having a resource. Are there any modules that you have that look at those things?
Yeah. So this is an example. So these are the 3 commitments in this case. And we can see the usage right here. And if you have a recommended new commitment, we will put that plan here in the recommend. Right now, there is no recommendation, but otherwise we'll show it here.
All right. So if I had been, if the autonomous system has been seeing my environment for a long time, it may recommend, hey, pull the trigger on some commitments.
Correct.
And save you. Okay. Oh, that's cool.
Exactly. And you can divide the cost by cloud provider, by groups. You can create groups within SEDI itself. There could be a dev group, there could be a test group, or there could be a payment group. You can do group in multiple different ways, and you can segment SEDI based on that group. Group is a first class citizen here. Perfect. And let me also show you one other thing. So again, autonomy is new at this. So I want to make sure that we are not expecting people to onboard this journey in one shot. That's where you can see that it's a journey for every customer. So we generally start with data pilot. We call it read only, your current scenario, which is where the cloud cost explorers, that scenario, where we show you just the recommendations. And then we call it co-pilot, the automated scenario, which is all tools except SEDI. This includes every other optimization tool. That's the co-pilot. That's a 5-year back scenario where you could click and execute those optimization, or you could configure those optimization. And the third is autopilot, where you say, you know what, now I want to use your intelligence and you take the responsibility. At this point, SEDI owns the responsibility. It's our models deciding what needs to be done, and it's going to be the safest execution ever. This is only available in SEDI today. Not any competitor, not even the 3 clouds, they have autonomous execution anywhere. That's only provided by SEDI. That's why these largest companies are with us.
Do you have the large companies? I'm sure they had FinOps departments, FinOps tools. Was there, even though those tools would make recommendations, did those companies have like armies of program managers trying to chase down teams like, hey, change this configuration so we can save some money? Is that were they actually trying to do it in a manual fashion and just couldn't keep up?
No, they had tools. So when we Yeah, I don't want to take names there, but again, when we went to a large company, they had, I think, Zesty and Cast or some tool like that, and there were tools in play, right? And generally, when we come in, they'll try not to do the same fashion. They don't go behind people; they just execute it.
Yeah, so the tools were there, but just without the ability to have an autonomous system make the changes, it was just too hard to implement any changes to make a meaningful impact.
Correct.
All right, cool. Any well, not any sections, but on the recommendations on the autopilot, say on some, if you've ever looked at other tools for people out there, maybe it recommends take 8 gig of memory, squish it down to 4 gig. That's what we're recommending. Someone goes off and does it by hand or through pushing it through Terraform. If Sadaya thinks that it wants to go from 8 to 4, does it jump straight from making that reduction, or does it approach it in an incremental fashion?
It is an incremental fashion, and again, it is not truly just incremental. It has a safe path to go to 4. Right, so that's exactly our unique thing. That's why we have all these patterns, right? These things monitor that path and make sure that that's the safest path to go to 4.
So it'll maybe move it down a little bit, keep watching the system. Are there any errors or anything? Performance is good, and then squeeze it down a little bit more?
Yes. Yeah. It's a model deciding that path similar to that. Yes.
I'm probably being too simplistic on it, but I'm sure it's pretty complicated.
Yeah, it is a little too simplistic because at times even a small change could cause a problem. Right? That's why generally people don't make the change. So that's why we look for traffic. We look for traffic patterns. We look for the peak where this change is not a change anymore. Right. So there are multiple ways to do it. Although it appears to be a decrease, it's not a decrease because you have seen that in higher traffic. I'll give you a small example, right? So let's say there's an application that's running at 5% CPU at all times, but you have seen this handling 10% CPU and peak traffic, which means now you know that at least in 10% it doesn't fail. That is a good reason for you to increase it to 10, because you at least know that it doesn't fail and it has done the same traffic at a reasonably same latency, which is your safe net now. So that's why this learning helps. It understands all the behaviors and it now knows these are the safe things that you can turn the knobs and it will never crash.
And which things are you optimized out? So we've seen Kubernetes. Are there other parts of my cloud that you'd be looking at and helping optimize the operations and optimize the performance and optimizing the cost?
Yes. We started with serverless. Then we do Kubernetes on all 3, ECS on AWS. We do VMs on all 3. We do data flow. We do S3 EBS. What else? RDS. Storage on Azure. We are now getting into BQ in GCP.
Okay, so there's like the heart of what you'd be using in cloud across the multiple clouds is there, and then adding on cloud services as a customers ask for it, or as it makes sense.
It is generally what customers ask for. There is also an industry pull. So Databricks is a market ask. So there are a few customers interested, and also we feel the market is using Databricks a lot. So Databricks is also coming. So the essence is that we have built an autonomous engine. Now it can drive a car or a bike or a motorcycle or a truck, right? So we are just putting that engine on multiple things. That's why we are generally a cloud optimization platform, while most others are either Kubernetes or serverless or database.
Mm-hmm. All right. Any of the features or thoughts on how the system works that you wanted to tell us, but didn't quite get to it yet, or I'm sure there's a lot more behind the scenes. We're reaching about the hour point, and just want to make sure you have a chance to hit all the high points.
Yeah, so there are some other features, some other quick features that I thought was interest to a few customers. I don't know how useful it would be for this group, but you can create groups and you can schedule rules there. And there is also scheduled shutdown on everything. So if you have a cluster that can be shut down on weekends and we can learn, we generally suggest you a window. Otherwise, you can also have a schedule for shutting down those resources too.
Okay, so in my development environment, I don't have to invent my own solution to shut everything down. That's just an extra thing there, shut everything down. And if you have a company with multiple time zones, can there be multiple kind of shutdown periods?
100%.
All right. No, that's great. And that's one of the great thing about cloud. You only have to pay for what you use. The bad part is you have to pay for what you use. And the easiest way to stop spending money is to just shut it down. So that's
Yes.
that's like a great simple feature to have for people.
Yeah.
I don't know if the feature is simple, but it's a simple concept. Shut it down when you're not using it.
Yeah. 100%.
All
By
right.
the way, again, I generally do not take names of competitors, but all these companies, like be it any FinOps company, Cloud Health, Cloud Ability, Cast, FinOps, NOps, ScaleOps, all these companies, they all add value, right? So they all have there for a reason. They all do their automated work. It's just that we are just different from them. That's all, right?
Mm-hmm.
They all have their own value. There is reporting value there. And we generally are the autonomous system. And we believe that showing these reports is not enough or asking them to click is not enough. It is time for us to take the responsibility. And that's where we said this autonomous system can learn, understand, and operate on your behalf than asking you to give approval.
Mm-hmm.
So that was the essence of building Sedai, and that's why we are continuing this run.
All right, looking at the chat, if you guys have any more questions, let me know. Put them in the chat. For those that didn't make the first part, maybe they were traveling or maybe they joined late for whatever reason, trapped in a meeting. The session is recorded. I'll put it up on YouTube and then link it to the GDG site from the same page that you joined the meeting from. It'll be there. Just scroll all the way to the bottom. It shows up a section at the bottom, and you can catch up on what you missed. I do have one non-technical question, Suresh, that I ask all our presenters. Sometimes we get some younger people still in college or early career. So I'd like to ask a career question. So as looking ahead, knowing what you know now about technology, knowing what you know now about careers and how they progress. Any particular tip or tips or guidance that you would give to someone that's just starting out in their career?
Yeah. One, I think the ones who are starting a career are the smartest in the world. So they are the ones who should probably tell us what to do, right? So that's my thinking. Because those are the fresh minds. They don't know what's possible, which is also a good thing, right? So they don't know what's the limit either. So they will think beyond limits and they will show us what can be done. I learned it from my mentor, Sri. So he always called it curiosity quotient. And that's really a thing that you should have and work extremely hard. So these are the two things that you need to do to get your career to the best. And of course, please go to Sedai Careers. And if you like what you see, please apply. We would love to have you guys.
All right, so that's interesting. The curiosity quotient. Stay curious. Keep your mind open on what's possible, and work hard. So those it sounds like that could be a recipe for success for sure, and maybe show everybody else how how things maybe nobody ever thought of it before, and now the world is a better place because of it.
Yeah. Taking risk is always okay, because when I started the company, this community has supported me left and right. So I have never seen a person telling me that, okay, this is a new idea, I don't want to try it. Everybody's exactly the other way around. So you're trying something new. Tell me how I can support you. I thought sales will be hard. For an engineer, it's super easy. This community, you can just lean on them. You can ping anyone on LinkedIn. I'm sure they'll support you. So.
All right. No, that's great. So not seeing any more questions in the chat. Suresh, really appreciate the time that you spent with us, sharing your insight into not just FinOps, but an autonomous system that can monitor your application as it's running, and either suggest changes to make it run better or cost less, or autonomously do it if you trust it enough. Let it run, and maybe you get less pager phone calls in the middle of the night. Save some money in the meantime. Give your SREs and your engineers a little bit of rest by having an autonomous friend keep an eye on things for them.
Perfect. Thank you so much for the opportunity. It was awesome. It was a well-run group. So thank you, Jim, and thanks everyone for this opportunity. I really enjoyed it.